Um, Welcome to the deep dive. Usually when you set out to draw a map, there is this expectation of finality. You chart the mountain range, you draw the rivers, you mark the borders, print it out, and your job is basically done.
Yeah, the terrain is captured, it doesn't move.
Right, exactly. But when you step into the world of industrial training and attempt to create, like, digital twins of real-world facilities, that map is essentially useless the very second you hit print.
It really is. We are looking at an industrial landscape that just never sits still.
I mean, equipment gets swapped out, right?
Yeah.
Components get upgraded. Machines undergo all these custom modifications right on the floor.
It is the absolute definition of an infinite moving target.
Yeah.
You have facilities where literally no two assembly lines are exactly identical, even if they were built in the exact same year.
Which brings us to the core of our deep dive today. We are exploring a really fascinating release and an accompanying white paper from July 24, 2026.
Right, from EON AI Ventures.
Exactly, EON AI Ventures. And they've introduced this new architecture built inside EON Universal, which they are calling the Living Library. And our mission today is to understand how this specific architecture is attempting to solve what might just be the single most frustrating bottleneck in digital industrial training.
And it is a massive bottleneck.
Yeah, the fact that the real world has an infinite number of equipment variants, and static content libraries can just never, ever keep up. Okay, let's unpack this problem first to understand what we're actually up against here.
Sure, yeah. Let's set the stage.
Imagine you were tasked with training a workforce, right? Maybe they're operating massive, heavy machinery in an underground mine, or perhaps running life-saving, highly complex hospital equipment.
High-stakes stuff.
Very high stakes. Traditionally, if you want to build a 3D training module for just one of those assets, you were looking at a cost of somewhere between $500 and $2,000.
And that's just for one single variant.
Right, just one. And it takes days just to model that one single piece of equipment.
And we really have to extrapolate that math to understand the true scale of the paralysis here. I mean, think about it. If you manage a facility with thousands of unique assets,
Oh, wow.
or a global enterprise with tens of thousands of machines, paying $2,000 and waiting several days for every single variant is economically and practically impossible.
It would completely bankrupt the training budget before you even mapped out a single factory floor?
Exactly. You literally couldn't do it. And it is important to establish the stakes here because EON AI Ventures isn't some, fresh startup guessing at this problem.
Right, they have a serious track record.
Very serious. The leadership behind EON Reality brings 25 years of experience in immersive learning. I mean, they are serving over 4,400 institutional customers across more than 80 countries.
So we're talking about deep, entrenched experience here.
Yeah, providing solutions for safety-critical industries. And after all those years, they realized something pretty fundamental. Attempting to model the entire world in advance is just a fool's errand.
It just doesn't work.
No. There is a pivotal quote in the release from EON's founder, Dan Jerskar, that perfectly frames why they had to completely change course. He said, "Nobody can pre-build reality, and everyone who has tried has failed."
Wow. I mean, that is a really stark admission for a company in the business of digital modeling. Everyone who has tried has failed.
But the logic absolutely holds up.
It really does. I mean, if you operate 1,000 different water treatment facilities across the globe, you possess 1,000 entirely different configurations of like valves, pressure monitors, and pump engines.
Right, no two are the same.
The sheer mathematical reality of trying to pre-build every single one of those configurations is staggering. So EON decided to stop fighting the infinite complexity of reality. They just fundamentally shifted their approach.
They stepped off the treadmill.
Exactly. They moved away from the endless treadmill of extensive, slow 3D modeling and introduced a completely new paradigm. They decided to start teaching their system by class instead of by serial number.
Which is a profound shift in data architecture.
Right. And to make this click for you, think about how human beings actually learn. It's like teaching a child what a car is.
Okay, I like this analogy.
If you want a child to recognize a car, you don't sit them down and show them a flashcard for every single make, model, year, and paint color ever manufactured in the history of the world.
No, of course not. You would never finish.
You'd literally be there forever. Instead, you teach them the archetype of a car. You explain the core components, right? It has 4 wheels, it has a steering wheel, it has doors, it drives on a road.
The foundational concepts.
Exactly. And once the child understands that archetype, their brain does the heavy lifting. When they see a brand new Honda Civic parked on the street, one they have never ever seen before, their brain automatically categorizes it.
What's fascinating here is how EON translates that cognitive concept of archetypes into a software architecture for complex industrial machinery. Because instead of chasing every individual serial number on a factory floor, EON builds about 50 photorealistic equipment families per industry.
Wait, just 50?
Yeah, about 50. And these 50 families serve as the archetypes. And we aren't just talking about rough visual approximations here.
They aren't just generic blocky shapes.
Not at all. These archetypal models are perfectly scaled to real-world dimensions. They are meticulously labeled down to the individual buttons, the safety latches, and all the internal components.
Oh.
Yeah, they establish an incredibly robust, perfectly accurate baseline for an entire class of machine.
Okay, establishing the baseline makes total sense. But the baseline doesn't solve the actual problem of the infinite variance out in the field, right?
Well, this is where it gets interesting.
Like, how does the system handle the moment a worker walks up to a machine that isn't perfectly represented by one of those 50 baseline archetypes?
This is where the workflow flips from static to dynamic. Let's say a worker is out in a real facility, right? And they encounter a specific make and model of a pump that EON Universal Recognition does not currently have in the library.
Okay, a totally unknown variant.
Exactly. In the old paradigm, that worker would have to put in a request, initiate a multi-day modeling contract, spend $2,000, and just wait.
The bottleneck.
The bottleneck. But in the living library paradigm, the system uses simple photographs taken of that new variant to generate the exact 3D model in a matter of minutes.
Minutes.
Just minutes. And it is registered into the active library on that exact same day.
Okay, wait, I have to stop you right there. I need to push back a bit because that sounds like a massive oversimplification of how 3D generation works.
Okay, fair enough.
If an AI is just whipping up a 3D model from some photographs on a phone in a few minutes, isn't that just generating like a superficial shell?
I see where you're going with this.
I mean, we have all seen 3D photogrammetry scans from smartphone apps. They might look pretty on the outside, maybe the textures are nice, but they're completely hollow.
Right, they have no internal data.
Exactly. A dumb 3D scan doesn't teach an aerospace mechanic how to fix an engine turbine. It doesn't have the internal logic, the moving parts, or, the safety protocols. If EON is using this for industrial training, a hollow geometric shape is basically utterly useless.
That is exactly the right skepticism to apply here, because a holoscan would indeed be completely useless for training. And this brings us to the core brilliance of their architecture.
Okay, lay it on me.
It's a concept they call intelligence inheritance. Because this entire system is built on those 50 foundational families, a newly captured variant is never just a dumb 3D scan.
So it's somehow connected to the archetype.
Exactly. When the AI generates the new model from those photographs, that new variant is born already knowing everything its archetype family knows.
Wait, really? So it's not just mapping pixels, it's mapping meaning.
Yes.
Let me see if I have this straight. It's like giving an AI a highly detailed blueprint of a human skeleton, complete with medical data about how joints work and where major arteries are. If I then show the AI a 2D photograph of a brand new person it has never seen, it doesn't just scan the surface of their skin. It automatically snaps that photograph over the existing skeletal blueprint.
Yes, exactly.
So instantly, just from a photo, it knows exactly where that specific person's elbows bend and where their heart is located.
That is an excellent analogy. The intelligence doesn't live in the new photograph, right? The intelligence lives at the family level.
Okay, that makes so much sense.
The new same-day model instantly inherits the underlying anatomy of the machine class, but it goes far beyond just physical anatomy.
Like what else?
Well, it inherits the operation protocols. It inherits the make-safe procedures for shutting it down safely. It inherits the known failure modes for that entire class of equipment.
Oh, wow. So it's fully interactive right away.
Yeah, it is not just a picture. It becomes a fully functioning digital twin of that specific variant, instantly populated with the complex, interactable training data of its parent class.
So you get the speed of a dumb scan, but the depth of a hand-built model.
Precisely. And, the impact on scalability here is just massive. They have taken an open-ended, endlessly expensive modeling contract, the old attempt to mirror an entire real-world facility piece by piece.
Which we established was impossible.
Right. And they turned it into a bounded, highly predictable exercise. You can build out an entire 50-family industry wing, complete with photorealistic HD textures and interactive cutaway views in a matter of days.
That's incredible.
The library literally grows exactly one machine larger every single time it encounters a machine it doesn't already know. As Dan Lajurscar put it, the library is alive.
Okay, here's where it gets really interesting. Because a library that is alive and growing at that kind of accelerated speed sounds like a total organizational nightmare waiting to happen.
It absolutely could be.
I mean, if you have a system generating models and inheriting data this quickly across thousands of facilities,
Right.
how do you prevent it from just turning into a chaotic, unsearchable mess?
You need serious structure.
Yeah. If I am a hospital administrator, I don't want my nurses sifting through a database filled with deep-sea drilling equipment just to find a ventilator training module.
Which is the exact structural risk EON had to engineer around from day one. To manage this massive, self-growing repository of knowledge, they organized it using an architectural framework they call One Museum, Four Wings.
Okay, 4 wings.
They didn't just throw everything into a single bucket. They launched with a massive scope divided into 4 strictly defined initial industries.
Right.
First, you have the medical wing. This covers infusion pumps, ventilation systems, patient monitoring, imaging like MRI machines, surgical tools, sterilization units, and laboratory equipment.
That is a highly regulated space.
Extremely regulated. Then the second wing is Aerospace MRO. That's maintenance, repair, and overhaul.
Got it.
This wing includes aircraft power plants, landing gear, hydraulics, and avionics. And they specifically organized this wing by ATA chapter.
Oh, the ATA chapters being the standard reference system for commercial aircraft documentation, right?
Correct. Which means the digital library aligns perfectly with the deeply entrenched regulatory workflows the aerospace industry already relies on. They don't have to learn a new system.
That's smart.
Yeah. The third wing is mining, which handles heavy excavation, haulage, crushing, conveying, and processing equipment.
Huge machines.
Right. And finally, the fourth wing is oil and gas. This was actually the founding wing of the architecture. The oil and gas wing is already more than 340 components deep and has been thoroughly proven in a training pilot with a major operator.
You know, what stands out to me about those 4 specific industries, medical, aerospace, mining, oil, and gas, is that none of them are casual environments.
No, not at all.
They are all highly regulated, intensely equipment-heavy, and absolutely safety-critical. These are fields where training bottlenecks don't just cost money. I mean, lives.
The stakes are as high as they get.
But returning to the architecture, if they are separating all this data into 4 distinct wings, how is this different from just building 4 completely separate software products?
Well, if we connect this to the bigger picture, this is where the One Museum part of the concept does the heavy lifting. The strict segregation of the data is mandatory. As the white paper notes, a hospital never sees a dragline.
Right, so the nurse doesn't see the mining drill.
Exactly. A nurse training on a ventilation machine will never accidentally pull up the failure modes for a massive piece of mining excavation equipment. The databases are strictly walled off.
Okay.
However, while the content is strictly segregated, every single wing sits on top of and shares the exact same intelligence engine.
Oh, meaning they don't have to rebuild the underlying software features for every new industry they tackle.
Exactly. Regardless of the industry, every wing inherits the same powerful platform tools.
So they all get the upgrades at the same time.
Yes. They all use the same optimized 3D viewer. They all utilize the same underlying procedure engine that guides a user step by step through a task.
That's huge for efficiency.
It is. They all have access to the same Cutaway see-inside teaching views, which allows workers to visualize internal mechanics without taking a physical machine apart. And crucially, they all utilize the identical competency tracking system to measure whether the workforce is actually absorbing the knowledge.
So the engine runs everything.
Yeah. By sharing the engine but segregating the data, they prove the cross-industry viability of the whole system. The source notes that the medical pilot is live right now, operating right alongside hundreds of smart components already in production across the oil and gas and mining sectors.
Well, the efficiency of that shared engine is undeniable. But this entire conversation brings up a massive flashing red light for me.
Yeah, what is it?
We just established that these are safety-critical industries. In a surgical suite, on a deep-sea oil rig, or while repairing a commercial jet engine, you just cannot afford an AI hallucination.
Absolutely not.
If an AI system maps a 2D photograph to the wrong archetype and gets a pressure valve wrong on an oil rig, things go boom.
Yes, they do.
If it mislabels a single dial on a medical infusion pump in a training simulation, patients could literally die. The stakes are absolute. So how does EON ensure this rapidly self-growing photo to 3D AI library doesn't learn the wrong things and, pass those fatal mistakes down to the workforce?
It is the single most critical question you can ask when deploying generative AI in any industrial environment. And EON is hyper aware of this, which is why they operate on a strict philosophy they call human-gated by design.
Human-gated by design.
Right. Yes, the underlying AI can generate a variant in minutes. Yes, the photo to 3D mapping allows the system to scale infinitely. But despite all of that automated speed, every single AI-generated model is hard stopped before deployment.
Really? Hard stop.
It must pass a human blessing gate before it ever reaches an end user.
A human blessing gate. So an actual qualified subject matter expert has to look at the AI's homework and say, yes, this is accurate before it goes live.
Precisely. It is not an autonomous loop. It requires a deliberate human approval. And EON applies a really rigid discipline of accuracy to this blessing process.
What kind of discipline?
They employ 3 specific guardrails. First, they use fidelity labels. So any user logging into the system knows exactly how precise the model is and how it was generated.
So no guessing.
No guessing. Second, they use sourced dimensions, meaning the scale of the generated equipment isn't an AI guess. It is mathematically verified against real-world data.
Okay, that's crucial.
And third, they mandate specification-driven part naming.
What does that mean in practice?
It ensures that every button, every valve, and every single monitor is labeled in the digital twin exactly as it is named in the original manufacturer's technical manual.
No creative AI names.
Exactly. EON considers this strict discipline, the act of keeping the generative library honest, to be just as important as the generative technology itself.
That makes perfect sense. The generative AI is just the engine giving you speed, but the human blessing gate and the strict naming discipline are, well, they're the steering wheel and the brakes.
Right.
If you have a massive engine but no steering wheel in a safety-critical environment, you are just going to drive off a cliff much faster.
That's a great way to put it. And that rigorous discipline is what ultimately transforms this from like a neat training trick into a compounding asset for the entire enterprise.
A compounding asset.
Yes. In their release, EON refers to this final verified output as work intelligence. They don't just view these models as temporary training modules you use once and discard. They view work intelligence as an enterprise's missing system of record.
Oh, I see.
By capturing exactly how work is actually performed on these verified variants out in the real world, the enterprise is creating an owned, continuously compounding digital asset.
The source material also drops some pretty heavy terminology around this broader vision. Things like one system, human 2.0, and the intelligence flywheel.
Yeah, a lot of buzzwords.
When you strip away the branding, what are the actual mechanics of that vision?
At its core, it all comes down to a continuous feedback loop. One system is just their overarching architecture. Within that, you have the intelligence flywheel.
Right.
Think of the flywheel as the mechanical process we've been discussing. A worker takes a photo, the AI generates the variant, a human expert blesses it, and that new accurate data is fed back into the archetype.
So it just keeps learning.
Exactly. As that flywheel spins faster, the library becomes exponentially richer and more accurate. And the ultimate goal of spinning that flywheel is to create what they call human 2.0.
Which sounds like a sci-fi movie.
It does, but it isn't about replacing the worker with AI. It is about augmenting the human worker. A human 2.0 is just an industrial worker who has instant, verified, archetype-backed intelligence for any machine they walk up to, entirely eliminating the guesswork from their job.
So what does this all mean? When you step back and look at the sheer scale of what we've unpacked today, the implications are just profound.
They really are.
This is fundamentally about changing how human knowledge is captured and scaled in the physical world. For decades, the tech industry thought the answer was to just throw more processing power at the problem, to try and pre-build every single grain of sand on the beach.
Which we know doesn't work.
Right. EON AI Ventures has essentially proven that the best way to handle the infinite complexity of reality isn't to fight it. You don't pre-build everything.
No.
Instead, you create incredibly smart, data-rich archetypes. You provide a frictionless way to capture new variants, and then you just let reality fill in the blanks.
Yep.
You let the daily operations of the world teach the library. It is a completely inverted way of thinking about industrial training.
It is an inversion that solves the primary bottleneck of the industry. But, if we follow this trajectory, it leaves us with an incredibly provocative concept to consider.
Ooh.
Well, If this living library continues to grow exactly as they have designed it, capturing how work is actually done across thousands of global facilities, day after day, logging variant after variant, and tracking every make-safe procedure and failure mode, does this library eventually stop being just a training tool?
What else would it be?
A predictive blueprint.
Oh, wow.
Think about the data accumulation here. If every specific variant, every maintenance quirk, and every failure mode from every corner of the globe is continuously uploaded, verified, and connected back to the family archetype, the intelligence compounding in that flywheel will be staggering.
So it could predict when things break.
Exactly. This system might very soon understand the exact lifespans, the operational quirks, and the breaking points of global industrial machinery better than the original manufacturers who built the machines in the first place.
Because the manufacturer only knows how the machine was designed to work in a pristine lab. But this library knows how the machine actually degrades and fails in a dusty mine in Australia or a deep-sea rig in the North Sea.
Exactly. The map doesn't just reflect the territory anymore, it starts predicting the landslides.
The map predicts the landslides. That is an incredible thought to end on. Thank you for joining us as we explored this shift in how we capture reality. Keep questioning how the systems around you are built, and the next time you are overwhelmed by an endlessly complex problem, maybe don't try to memorize every single variable. Just start by figuring out the archetype. Catch you on the next deep dive.